Today we are going to create a new ServiceStack app and have it running on AWS Lambda using containers. In December 2020, AWS announced support for running Lambda functions in Docker containers. This enables the use of standard Docker tooling and automation rather than using Lambda layers and zips, which are annoyingly specific to AWS. First, let's deal with some prerequisites. You'll need .NET Core SDK that supports .NET 5 or higher, the AWS .NET Core CLI, and of course an AWS account. To kick us off, we're going to use the ServiceStack.NET tool X to create our project based on our new AWS containers template. If you don't have this installed, you can just run .NET tool install -g x. Once installed correctly, you'll be able to see the selection of templates via the command xnew. Let's get started. The X utility allows ServiceStack templates to be created using the syntax xnew, the template name, and then your app name. So let's create a new ServiceStack app using xnew AWS Lambda space ServiceStack Lambda. Once created, you can open the solution normally. In this tutorial, I'll be using JetBrains Rider, but the same will work for VS Code or Visual Studio. In this template is an empty web application that runs normally locally, but once deployed to AWS Lambda, uses a wrapper from AWS. This wrapper is located in your local project, generated by the template, and called lambda-entrypoint.cs. The other three AWS-specific files to this template are AWS Lambda tools defaults.json, which contains default values the AWS .NET Core CLI will draw from when it's being used. The Dockerfile, which inherits from the AWS provided base image to host our Lambda function using Docker containers. And serverless.template, which is the CloudFormation template used by AWS .NET Core CLI commands like .NET Lambda deploy serverless. When running locally, none of these files are used, but all the ASP.NET and ServiceStack code is shared and consistent, making for a familiar local development workflow. Using your normal IDE run or debug command, we can see that it runs locally as shown. Now we have a running application, let's look at what needs to be done to get this auto-deploying to AWS Lambda. We can utilize GitHub Actions to be our CI runner. So first we want to get this project up onto GitHub. In Rider, it's as easy as using the built-in Share on GitHub integration to put our newly created project straight onto GitHub. To help things along, the template includes a GitHub action to automate this build, test, and deployment and utilizes the AWS .NET Core CLI. This is to make it easy to have an automated CI environment set up from the very beginning. The action will try to run for the first time, but we still need to fill in some details about our AWS environment. Specifically, a deploy AWS user with the required permissions, and an S3 bucket to deploy stack info to. You can create a new S3 bucket or use an existing one if you've got one. Just be sure the S3 bucket that you use is in the same region as your stack, as this will be required. Once created, copy the S3 bucket name into the project file AWS Lambda tools default.json, where it says your S3 bucket. Now to create your CI deployment user. In this template's README, we've provided an IAM policy of permissions that can be used to create all the required AWS resources. Since this is creating a whole new stack using multiple managed services, there are a lot of permissions required. Once the stack is created, this policy could be changed to have less permissions, as iterations and updates don't require the full permission set. Copy the policy JSON from the README and create a new policy within your AWS environment using the provided JSON. Create a new IAM user with programmatic access, attach your newly created policy, and download the generated credentials. We'll need these credentials to set up the GitHub repository secrets for our GitHub Actions worker to authenticate with AWS. To set up this authentication, we'll need to match the names of our GitHub secrets to match the names our AWS GitHub Actions is expecting. If you navigate to the repository and open the ci.yaml file located in the .github/workflows directory, you'll find the reference to the AWS access key and the secret names required by the AWS GitHub Actions step. These will be under the AWS login step, and the secret names we want to create will be AWS_access_key_ID and AWS_secret_access_key. We need to create secrets with the exact same name so that this step can utilize that info to authenticate with AWS. Copy the access key name, paste it into the new secret page along with the value from your downloaded deploy user credentials. GitHub secrets can be found under the repository settings page. Do the same thing with the secret key and you'll be set to go. Navigate back to your local project and commit the updated S3 bucket name in the AWS Lambda tools default.json and push this change to your GitHub repository. This will kick off a new set of GitHub Actions workflow that will run from the very beginning. As you'll see in the logs, the command being used is the .NET Lambda deploy serverless command. This comes from the AWS .NET Core CLI tooling that handles building our project, Docker image, and the AWS resources via the serverless.template file. Once finished, our Lambda function is now deployed to AWS. However, it still isn't very easy to use. If you want to use this as a normal-looking public-facing ServiceStack application, we need to wire our new Lambda function to a subdomain. We can do this by configuring a custom domain within the API Gateway console and directing a subdomain with an A record to this API Gateway mapping. To do this, open API Gateway in your AWS console and create a new custom domain. You'll also need a TLS certificate for your custom domain. The easiest way to create one of these is to follow the prompt in the Create Custom Domain page and use AWS Certificate Manager or ACM. Specify your certificate in ACM and click Create Domain Name. Once created, you'll be able to create the new API mapping for this custom domain. Point this mapping to your prod stage of your new Lambda container deployment and hit Save. Each custom domain has an API Gateway domain associated with it once it's created. To get this working with a friendly subdomain name, copy the API Gateway domain, navigate to Route 53 and a hosted zone of your own, and create a new A record pointing to the API Gateway domain that you've copied. Once saved and propagated, we can now navigate to this public-facing subdomain and see our ServiceStack application running and ready to use, hosted in AWS Lambda. A written guide to this walkthrough is available in the README of the template to follow along at your own pace. It also talks about some of the latency limitations around AWS Lambda related to cold starts and possible workarounds. In general, this pattern can be useful for cheaply hosting fully featured ServiceStack applications that have low request numbers. AWS Lambda and other serverless technologies can start being expensive as request numbers rise, but they do allow scaling infrastructure to be much more simplified. I hope this video was useful. If you have any questions or feedback, please let us know, and thanks for watching.